Okay, let's use this series as a kicking off point for a discussion. So we've got a series of numbers, so the nth term is just equal to something over something plus 1, so n over n plus 1. And in the next term after that, we obviously see an n, replace it by n plus 1, so n plus 1 is n plus 2. So there's my terms, so forming the ratio, and it's going to be n plus 1 over n plus 2 times the inverse of the un, and then we can expand the bracket, so it's effectively in brackets. So the top line is going to give us n squared plus 2n plus 1, and on the bottom we're going to have n squared plus 2n. And then we can do our limitation thing. So the limit as n goes to infinity of un plus 1 over un is the limit as n goes to infinity of what we worked out there before. And we're going to apply our normal stunt of dividing by, in this case, n squared, because it's the largest power. So we get 1 plus 2 over n plus 1 over n squared over 1 plus 2 over n. And as we let n go to infinity, that one goes to 0, that one goes to 0, and that one goes to 0 double quick. So all we're left with is 1 over 1, which is 1. So in this case, the limit as n goes to infinity of un plus 1 over un is equal to 1. So the ratio test is inconclusive. It doesn't tell us what's going on. So we need to have some other way of doing it. And in this case we can actually know, because if we look at the individual terms, you'll see that they're getting bigger. Half, 2/3, 3/4, 4/5. The individual terms are not heading towards 0. Okay, or if you want to write that more formally, the limit as n goes to infinity of an individual term is not equal to 0. So we know that this is a divergent series. Okay, so even though the ratio test is inconclusive, the basic idea of terms have to be heading to 0 for it to be conclusive is able to be used, and we can see quite clearly that this is in fact a divergent series.